Hi, this is Mrs. Marquette. This morning we're going to be talking about solving some radical equations. So we've already this year solved a whole bunch of different types of equations. Today we're doing anything that has a radical in it. So before we actually solve some equations, we're going to try just evaluating a expression that has a radical in it. Specifically, we're going to look at when x equals 4. Remember that evaluating when x is a particular number, we're just plugging that number in and then seeing what comes out. So x equals 4, if I look at number 1, I'm going to copy everything down except instead of x, I'm going to put in a 4. Okay, and then I can just simplify using order of operations. Something to be aware of is that if I have that square root symbol or any really radical symbol, I really have like invisible parentheses sitting there. So it's like everything under there is under a grouping symbol. So under that radical, I can do 10 times 4 is 40 minus 4, still in grouping symbols. So I still have the radical, 40 minus 4 is 36. And we know that the square root of 36 is equal to 6. Okay, that's not a plus or minus 6 because we didn't take the square root. It was already there in the problem. Number 2 is going to be super similar, except this time I have a third root. So I copy everything. So the third root of 3, x is still 4 minus 4. There are invisible grouping symbols. So this is equal to the third root of 12 minus 4, or the third root of 8. We know the third root of 8 because 2 times 2 times 2 is 8. So the third root of that expression is just 2. So we're actually going to use this today. After we're done solving, we're going to use evaluating to make sure our answer is true. So I'm just going to talk about solving radical equations. Solving radical equations is just like solving any other equation. We are still going to use PEMDAS backwards. Okay, meaning that we're still also going to use inverses. So today, adding is always going to go with subtracting. Multiplying is always going to go with dividing. And the two ones that we're focusing on in this chapter is that exponents go with radicals. So squares go with square roots. We've already talked about undoing a square with a square root. Today we're going in the opposite direction. We are going to undo a radical with a square, and we are going to undo an nth root with an nth power. So they say the key here is to raise each side of an equation to the same power. So if a equals b, then a to the n equals b to the n. This is what's going to be on your guide. Now, instead of just like adding a number to both sides or multiplying on both sides, I can also raise a power on both sides to get like x by itself or get a side by itself. Before raising each side, we should isolate the radical expression on one side of the equation. That's PEMDAS backwards. That's all of this that we're really used to. The last thing they say is we're going to solve and we're going to check for false solutions. All that means is we're going to check that our answer is right. Sometimes when you're working with radicals, not very much in this chapter, but sometimes you're going to get answers that just don't work. But what we're really going to check for is, did we do our work right? When I plug my answer back in, does it make the equation true? So to start, we have the third root of x minus 4 equals 0. PEMDAS backwards, I'm going to add 4 to both sides. So I get the third root of x is equal to 4. Now, I don't have anything left to multiply, divide. I do technically have grouping symbols under my radical, so I can't do anything to that x yet. What I need to do is get rid of this 3. So you get rid of a radical by raising both sides to the same power. And we know that third roots and cubes will undo each other because it's the same root, same power. So I get x is equal to 4 to the third. If you plug that into your calculator, or if you know that off the top of your head, x is equal to 64. Now x is by itself, so that's our final answer. Then we're going to check. To check, we're literally going to plug in the answer that we got, 64, in for x. So does the third root of 64 minus 4 equals 0. Well, the third root of 64 is 4. I can check that in my calculator, minus 4. So 0 equals 0, check. I do need to see that check every single time today. Even if you're plugging into your calculator, I still need to see it written over on the side. Number 2, again, PEMDAS backwards. There's nothing to add, subtract, but there is something to multiply, divide. 2 is currently multiplied, so I'll divide by 2 on both sides. I get x to the 3 halves is equal to 125. Now our goal, this one's a little different than the last one, but our goal is to have just x equals something, right? X equals something is the same as x to the first. So what could I raise this left side to in order to just get x to the first, or get x by itself? I know that if I raise a power to a power, I'm going to multiply the powers. So if I actually raise the left side to the 2/3, I'm going to have x to the 6 over 6, which is just 1. So on the right side, I'm also going to raise that side to the 2/3. So when you're trying to cancel out an exponent, you can multiply by the reciprocal or raise both sides to the reciprocal power. So then I get x to the first is equal to 125 to the 2/3. If you actually plug 125 to the 2/3 into your calculator, you will get x is equal to 25. Okay. We want to check that this is true. So we go check, plug our answer back into the original equation. 2 times 25 to the 3 halves equals 250. This time what I'm going to do is put it into my calculator. I'm going to put this entire side into the calculator. So I'm going to say calc, just so that I know as your teacher that you've actually checked. Then I plug in 2, parentheses 25, caret, parentheses 3 divided by 2, and I want to know, does that side equal 250? When I plug that in, I do in fact get 250, so I get 250 equals 250, and that is a true statement. Number 3, I'm going to star, just because PEMDAS backwards, we got to be a little careful here. If I'm adding or subtracting, this is actually a positive 5, so I can subtract 5 on both sides. Then I get negative the 4th root of x is equal to 5. And I have a negative in front of my radical, okay? If I really want to think about this, this is like negative 1 times that radical. So in order to get just the 4th root of x by itself, I can divide both sides by negative 1. Oh, and this should have already been a negative, excuse me. So then I get the 4th root of x is equal to 5. Now, I want to get rid of the radical. So you always have to do the opposite of what you're trying to get rid of, the inverse. So since I already have a radical, I'm going to raise both sides to a power. I got to match the power with the root. So I get x is equal to 5 to the 4th, which is 625, if I check that into my calculator. So I do 5 caret 4. And the check. I do 5 minus the 4th root of 625 equals 0. Again, I can plug this into my calculator. If I just do calc, 5 minus 625, remember that the 4th root is like the 1/4 power. I want to know, does that equal 0? I do end up getting 0 equals 0, check. Number 4 is actually a lot like number 2, so if you want to pause the video and see if you can finish this one off, try that. Otherwise, PEMDAS backwards means I'm going to divide by 2 on both sides, and x to the 1/4 is equal to 4. I want to get rid of that 1/4 power. Really what I want is to get just x to the first, okay? So to get rid of the 1/4, I'm going to raise both sides to the 4 over 1, because 4 over 1 and 1/4 will undo each other. So then I get 4 to the 4th, which is 256, and x is equal to 256. You don't really need that 1. That was just to help us see what our goal was. And to check, again, you have to check. You will lose points if you do not check. You do 2 to the 2 times 256 to the 1/4 equals 8. This you can plug straight into your calculator, the left side. So I will say calc 256 caret 1/4. And in fact, 8 does equal 8. Check. The last two, I'm going to do one, and then I think you should try the second one. If I'm doing PEMDAS backwards, I want to think about what should I do first. It's going to help you to remember that there are invisible grouping symbols under that radical. Because now I can see like that part's in parentheses. I can't go after that yet. I've got to subtract 2 on both sides. So then I've got radical 4x minus 7 is equal to 3. That's going to be important, again, to have those grouping symbols, because now I know that I can't just add 7 to both sides. Those are stuck in the parentheses. What I have to do is get rid of that radical, that square root. So how do I undo a square root? Well, this is like really a little too. So I can undo it by squaring both sides. Square and square root cancel. I get 4x minus 7 equal to 3 squared, which is 9. Now this is an equation that we know how to solve. We add 7 to both sides. 4x equals 16, and x equals 4. When you do this check, I think it's going to be easier if you actually do this one by hand, because there's a lot going on. My check is 4 times 4 minus 7 plus 2. I want to know, does that equal 5? Again, parentheses here. So I've got the square root of 16 minus 7 plus 2. Does that equal 5? Square root of 9 plus 2. Does that equal 5? And 3 plus 2, in fact, equals 5. So if you're feeling a little confident, why don't you try this one? Pause the video. Otherwise, I'm going to do it right here. Think about, where do I put my parentheses? My grouping symbol ends right here, so I'll put the parentheses around the 2x and 8. And then PEMDAS backwards means add 4 to both sides. Then I've got 2x plus 8 under the square root equals 10. I need to undo that square root. I can undo a square root with a square. I've got to square the entire side. That's why I put those parentheses, and parentheses on the right side as well. So square root and square will cancel. I'll be left with 2x plus 8 is equal to 100 this time, because 10 squared is 100. And then again, we just have a simple equation to solve. Subtract 8 on both sides. 2x equals 92. Divide by 2 on both sides. And x is equal to 46. Checking to make sure this works. Square root of 2 times 46 plus 8 minus 4 equals 6. Start PEMDAS, so I'm starting way inside the parentheses. 2 times 46 is 92 plus 8. Then I take a square root of 100. 10 minus 4. And 6 does equal 6. So this doesn't mean that 6 is my answer. My answer is 46. This check is just to make sure that the left side equals the right side, that it's a good solution. So that's my solving for today. Again, this is stuff that we've done before. Hopefully you can see that this is just one little new thing. You always undo radicals with powers and powers with radicals. Just pay attention to doing the opposite, so using the inverse when you're solving.